Okay, here we're going to look at who goes to infinity faster. And the reason is we might have a limit as x goes to infinity, where one thing might be on the top, another thing might be on the bottom, and we want to know who's going to win. If the top wins, you go to infinity. If the bottom wins, it approaches 0. We have all these functions, and we want to know which one goes to infinity faster. So we're going to look at the graph. If you're zoomed in too much, you might not see what actually happens. It almost looks like x to the fourth goes to infinity faster than 3 to the x. Now if you zoom out just a little bit, you can see the x to the fourth and the 3 to the x. If you go a little bit more to the right, you can see 3 to the x takes over, and it's actually going to infinity faster than x to the fourth. Now we're saying the one that goes to infinity the slowest is going to be a log, and you can see why. The log is really close to the x-axis. So the slowest one is the log, the medium one is a power function, and the fastest one is an exponential function. Is there anything faster than an exponential function? Well, I guess you could create your own function, like x to the x. So that's a really uncommon one. You probably wouldn't see that on the AP test, but you never know. It's better to be prepared. If you compare x to the x with 4 to the x, you can see that 4 to the x is actually higher until you get to 4. And then x to the x takes over. Okay, let's go ahead and try some of these examples. Limit as x goes to infinity. The bottom is just a power function, and the top is a log. The power function is the middle one, so that one's going to beat the log. The log is the slowest one. Since the bottom wins, it's going to equal 0. For our second limit here, we have a log, we have an exponential, and we have a power. On top, the biggest one is going to be the exponential. So we can ignore the log function. So now we're left with an exponential on top and a power on the bottom. Remember, the exponential wins. So the top wins, so this limit is going to equal infinity. Okay, in the first one, we have two exponential functions. So we just have to figure out which number is actually bigger. Okay, if I just look at the first two decimals, you can see that the bottom is going to be a bigger number. So the bottom wins, and so that limit will equal 0. For the second example, it's a little bit trickier. Because you're plugging in a negative, we're going to want to rewrite this limit. Now when I plug in the negative infinity, I just get pi to the infinity over e to the infinity. Now remember, pi is the bigger number, so the top wins, and this one's just going to give us infinity. Okay, on this example, we have an exponential on top and a power on the bottom. So the exponential is going to win, and this will just equal infinity. The second one is a lot trickier. If I plug a negative infinity in, I'm going to have something like this. And if we move the one on top down, it changes the power to a positive infinity. Since all the infinities are on the bottom, it's just the same thing as 1 over infinity, and that's going to equal 0. If it was equal to infinity, we'd have to be careful and count the negatives. There's 3 negatives here. Okay, in our first example here, we're going to ignore the log because the exponential function is much bigger. Be careful, you need to keep that minus on the 3 to the x. On the bottom, the biggest one is that creative function called x to the x. So we'll get rid of that power function. And in this case, the x to the x is going to infinity much faster than the 3 to the x. So it's just going to equal 0. On the second example, we have an exponential on top and a power function on the bottom. Even though the power is really big, as we go to infinity, the 3 to the x is going to win. So our answer to this one is just going to equal infinity. Okay, if I was actually doing this problem, what I would pay attention to most is that vertical asymptote. Only one of these functions on the right has a vertical asymptote at x equals -1. When x equals -1, only e has a vertical asymptote. It's the only one that would give you 0 when you plug a -1 into the bottom. Now, we'll go ahead and finish the problem the way they wanted us to. They wanted us to look at the horizontal asymptotes. First thing we can do is we can look at the limit as x goes to infinity. For a, you would get infinity. So it's not that one because you can look at the graph and you can see that it's approaching 0. For b, you have to rewrite it. It would be x over e to the x. And if we did the limit as x goes to infinity for that function, you would get 0, so that one's okay so far. Letter c, the top is going to win, so the limit as x goes to infinity for letter c would be infinity, and that's not allowed. We're looking for 0. For letter d, the bottom does have a bigger power, so the limit as x goes to infinity would be 0, so that one's okay so far as well. How about the limit as x goes to negative infinity? If I plug a negative infinity into letter b, I would get negative infinity over e to the negative infinity, but we can move it up and it would become e to the positive infinity. So I'm basically multiplying two infinities, but there's one negative, so the answer would be negative infinity. That means the graph would have to go down on the left side, and we're looking for something that approaches 0. So we could cancel that. What if we plug a negative infinity for d? We would get negative infinity over infinity squared. And because it's the same level of infinity, it's just x, we could actually cancel one of those. And our final answer would be 0, which is what we were looking for. So d is actually okay so far. So it looks like the only way to tell the difference between d and e is to look at the vertical asymptote. If you did that in the beginning, you would have been done with the problem in the very beginning. Okay, our last one is a little bit tricky because we said that exponential functions are much stronger than log functions. However, if you look at the inside of that exponential function, it's a 2/3 raised to the power of x, which is actually a decreasing function, so it does not even go to infinity. So anytime the number inside is between 0 and 1, you end up with an exponential function that's actually decreasing. You could move it to the bottom and give it a power of negative x. Then you could bring the negative inside. Now plugging in the infinity shows you that it's just 1 over infinity times infinity, so that would give you 0.